Wait.
Come here means turn on everything.
Okay.
No, citric acid cycle.
Wait. No. Wait.
Citric acid.
No. Wait.
Citric.
No. Wait.
Citric acid cycle.
Wait.
Citric acid cycle. Citric acid cycle.
Okay,
No,
good.
citric acid cycle. It has a 3 stage. Glycolysis has 2 stage. Preparatory, payoff phase. Preparatory phase, payoff phase. The first box was preparatory. The second was is payoff. Okay. Citric acid cycle has a 3 phase. Actually, not the citric acid cycle. The fate of protein, fat, and carbohydrate is 3 stage. Stage 1 is acetyl-CoA production. You see, until pyruvate is glycolysis. Pyruvate to produce acetyl-CoA is the end of the stage 1. Fatty acid also can produce acetyl-CoA, and we should learn later how in the next semester. Amino acid also produce acetyl-CoA. We learn it next semester. Acetyl-CoA, it's enter to the citric acid cycle. It's produced NADH, FADH2, nicotine amide dinucleotide, flavin adenine dinucleotide, reduced electron carrier, and they go to the mitochondrial respiratory chain, and this is the electron transfer and oxidative phosphorylation.
Stage 1 is what?
It's not, doesn't write here, it's written here. See? Preparatory payoff.
What's the main function of acetyl-CoA? Like the enzyme, what is to bind to?
To bind oxaloacetate and produce citrate.
That's the main function only.
Yes.
Okay.
Now, what should we learn? We just go through this, and please print it out or draw it by one, very big, and put it on the wall. Okay? That's here is important. Come here. The acetyl-CoA has how many carbon? 2 carbon. 2 carbon. This 2 carbon bonds to oxaloacetate by the help of the enzyme the name is citrate synthase. When in the exam they tell you, could you please write the reaction of citrate synthase? It means they want to produce citrate, synthase the citrate.
So all the 3?
What? This is plus this one, the name of enzyme. It's use water and go away coenzyme. Why the coenzyme has SH? Do you remember from today? Thiol group was active. No. Acetyl is CH3COO. Instead of OH minus, I have a SCOA minus. Instead of OH minus is SCOA minus. Coenzyme with sulfide minus and H is plus. Okay. Now, how many carbon do you see here? 4. Why the name is oxaloacetate? 2 carbonyl, and this is the acetic acid. Okay. These 2 carbon adds here, and the name is citrate. The name is citrate. 3 carbon, 3 carboxyl, 1 OH on the carbon number 2. Now I wanna change OH on the carbon number 2 to OH on the carbon number. No.
That's the same.
No.
2.
Yes, number
3.
Number 3. It's draw it very bad. I always draw it like this, COO minus, exactly like this, okay? But the OH should come here. Do you understand it? From number 2 to number 3. How can I do it? The name is citrate, the name is isocitrate. If the OH is carbon number 3, and see this is a 1, 2, 3, and these are 3 carboxyl group. The name will be isocitrate. By the help of the enzyme, the name is aconitase, and this is the intermediate. Should we remember? No.
It's missing H here.
Yeah, the H is here. Should we remember the cis aconitate? No, but that's very easy also. It remove one OH, water. How? Hydrogen and OH. This hydrogen and this OH is go away. Then add one more water. But the OH instead of carbon number 2 comes to carbon number 3. It means dehydration and then hydration. It's written dehydration, hydration. It means aconitase, first of all, dehydrate the citrate, produce cis aconitate, and then hydration happens and produce isocitrate. Now, the name is isocitrate dehydrogenase, the name of the enzyme. It means we should draw the isocitrate and get out the hydrogen. When the hydrogen is go to produce NADH, it means NAD plus comes here and NADH is produced. The first NADH on the citric acid cycle produced by isocitrate dehydrogenase. It's written here, this is an oxidative decarboxylation. Why oxidative? Because we get out the hydrogen. Lose the hydrogen is oxidation. Why decarboxylation? Because this carboxyl group is go away. I would like to make a colorful that one. Carbon number 2, carboxyl is go away. And this is the first carbon here. Understand it? It means the carbon of acetyl-CoA is go away. The acetyl-CoA carbon came from glucose. It means the first carbon of glucose is go away in the form of carbon dioxide. Then, what is the name of that? Alpha ketoglutarate. Alpha ketoglutarate. What is the glutaric acid? How many carbon? 1, 2, 3, 4, 5. 2 carboxyl, 3 carbon between. 2 carboxyl, 2 carbon is succinic acid. 2 carboxyl, 3 carbon between is glutaric acid. No, this is a carbon alpha. Why? Because this is a carbon after carbonyl. Alpha keto on the glutarate. Alpha ketoglutarate. Okay. The name of the next enzyme is alpha ketoglutarate dehydrogenase complex. Again, because of dehydrogenation, one more NADH produced. It was dehydrogenase, NADH, dehydrogenase, NADH.
I have a question.
Yes.
I know it's a stupid question, but
No problem.
like, when you say carbonyl group, what do you mean?
It's C double O.
It
means ketone.
Group?
C double O is carbonyl. C double O between is ketone. C double O on the head is aldehyde. C double O with OH, carbonyl with OH is carboxylic acid. You see? C double O is carbonyl.
It's with the hand too, right?
Yeah. Oh, okay. This one is the carbonyl.
Yeah.
Okay. I was confused.
Now, where is the blue?
Oh, you said blue first time. Like,
Blue.
no, blue. Blue.
Blue.
Yeah. You
No,
said,
I confused what I said. What I said.
no, you said blue. Where is the blue? That's good.
Really?
That's very good.
Yeah,
That's
very good.
right.
I improved my English.
Yeah, see?
No. Come here. Come. Lisa, positive answer. You should not be so much happy. Why are you tired? No? Do you need massage?
No, no.
Armand?
Do you need
Okay, now comes here. This CO2 is this carbon. And this carbon was this carbon. Okay, and this is again one of the carbon from glucose and pyruvate and glucose. Every other before.
Do you mean this one comes there?
Yes. And later you learn by fluorescence, they understand this one. Here the coenzyme A comes. What? Coenzyme A. This is the oxidative decarboxylation. Why oxidative?
Oxidation of
Lose hydrogen. Why decarboxylation? Because CO2 is produced.
Yes.
Sometimes in the exam when they ask, could you please write the reaction? The second question, what type of reaction occur? And the student write elimination, addition, substitution. No, this is the oxidative decarboxylation. Understand? No.
So basically, what we have to know about this is the whole cycle.
Whole cycle.
Basically, just this page, really good.
Yes.
And this explained here.
Yes.
Thanks.
And they are just a magnify of this one. If we learn that, every problem is solved. But the problem is learning of this one. No, the succinyl-CoA. First of all, what is the succinic acid? 2 carboxyl, 2 carbon between. Come here.
Comes here.
The S-CoA minus bonds to carbonyl group. This is a succinyl-CoA. Succinyl-CoA. And do you remember the succinyl? And CoA is like a cow.
What?
You remember? Succinyl of the cow. Cow is moo.
Oh,
yeah,
four.
cow. Yeah. No, this succinyl-CoA, okay,
I don't know.
by
what
the
you're talking about.
succinyl-CoA synthetase.
Yeah.
Succinyl-CoA synthetase. Okay. Remove the coenzyme A, produce one GTP or ATP, it depends, and produce succinate. No, this co is go away. The importance, sometimes on the exam they ask me, what is the difference between synthase and synthetase? The synthase doesn't need energy. The synthetase produce energy.
Wait, that doesn't need energy and that produce energy?
Yes. You see,
How's
no
that
energy,
different?
no energy transfer here. Just the water comes. This is synthase, and synthetase needs energy because we said a lot of words for that. Synthetase, but synthase is easy. No energy. Okay, understand me?
Yeah.
Where should I write it?
There.
Okay.
Synthase.
The question: what
This is easy to
is
remember.
the
Yeah, but we have to remember so much.
difference
We went through so many lectures. This not
between
few,
Yeah.
40
synthase and
hours.
synthetase?
We need
Synthase,
sleep. Honestly.
no energy, need. Okay.
Yeah.
Synthetase produce GTP. Good. Now, succinyl-CoA synthetase. The problem is when it's written here citrate synthase, the citrate produce.
Yeah.
It's written here succinyl-CoA synthetase, but the succinyl-CoA are removed, destroy, and produce succinate. Understand me? This is the name of the reverse
I
reaction.
have a question. For example, here the GDP and the phosphate, they're not even in this compound. Like, they just come here.
They
Why does-
produce GTP. They
Yeah,
are
but-
cofactor. They come here. They understand. There is no any phosphate here. When the coenzyme go away, go to the this, go to the hell, the energy release. This energy is catch up by this person. Phosphate inorganic and GDP and produce GDP. It means the energy is free there, and they are the person.
Yeah.
They are the person that just use the time and said, okay, energy, hug us and produce GTP.
When CoA goes away.
Yeah, when CoAs go away. It means there is no phosphate here.
Yeah,
The
and then-
inorganic phosphate comes,
Yeah.
use this energy by the GTP, produce GTP.
And I mean
Okay.
that, like, for example, can GTP be produced in another way?
Yes,
Why, like, I don't understand why, like,
because you see, this is a cow, and the cow like a grass. And this grass is GTP, and the cow, grass, GTP grass.
It's just the way it is.
Really, do you understand me? Because
Yeah.
of that I said it's a succinate CoA.
Uh-huh.
CoA is cow. Cow
Yeah.
get out the grass, and grass is GTP.
Okay.
Understand?
I
And
understand.
when the grass is go, the cow is go, the succinate remain. No,
no, that's
then.
not my question. Never mind.
It's just the way it is.
But that's to forget your question. Comes here, okay? Succinate dehydrogenase. Again, succinate dehydrogenase. But we want to produce fumarate. Do you remember today's morning? Because the name is fumarate, F, it's produced FADH. Understand?
Fumiyaki.
We want to produce fumarate.
Yeah.
We produce FADH.
Yeah.
Just FAD, it comes 2 times on the pyruvate dehydrogenase complex and here, just 2 places. That's very important. No. Again, what is the fumarate? 2 carboxyl, 2 carbon in a trans position.
Yeah.
Do you remember? They are in trans. You should put 1 hydrogen here, 1 hydrogen
There.
opposite. Fumarase, what? Fumarase come and aids the fumarate and produce malate. Malate have a 2 carboxyl, 2 carbon,
It takes
1
away
OH.
something. It's an enzyme, right?
Yes, it's take
That-
away double bond,
Yeah.
add water,
Yeah.
the water H and OH add.
Oh.
And according to Markovnikov, those
Which
carbon has a
becomes
high hydrogen, it should be higher, but they are same hydrogen, okay, no difference there.
Okay.
The malate dehydrogenase again produce 1 more NADH, and the hydrogenase happen, and you see 4 carbon, 4 carbon, H and H is go away. This H by this H go away, and it will be a C double O here, and it's produced again oxaloacetate. Now the question is, please pay attention a lot to understand the next pages. Is there any new carbon on the citric acid cycle?
Yes.
No. These 2 carbon was new, and they are fucked them out.
It was a 50-50. I just took my shot.
You see, these 2 carbon, are new and they are fuck out as a form of the
Why-
CO2.
Why do we have two?
Because these two carbon comes from acetyl-CoA newly.
They're two
Every
carbons.
other thing is constantly in this cycle.
Ah, yeah, okay, that's the product. I
Yeah.
was just
It means from when you burst until when you die, okay? They are same and equal in your body. No. Another
You
question.
want the carbons?
Yes, this cycle
in the
is same.
cycle,
This
the
carbon
carbons
is
will
very
never
old.
change.
One more
What
question.
happens if you like lose one?
What?
You can't lose one.
No, you never lose it. Don't
You
worry.
die.
No, you never lose it. Don't worry. Now, my question is, how many acetyl-CoA is produced from glucose?
How many what?
How many pyruvate produced from glucose? Two.
Two.
Yeah.
One pyruvate, one acetyl-CoA. Two pyruvate, two acetyl-CoA.
But it has
It
to go
means
2 times, right?
for one glucose, 2 times citric acid cycle.
Yeah, so two co-op.
Two acetyl-CoA.
Yeah.
One acetyl-CoA, 3 NADH. Two acetyl-CoA, 6. One acetyl-CoA, 1 FADH. Two,
Two.
and 2 GTP.
Can we just write it down? Like
No,
quickly?
do you understand it?
Yes.
No, now we should calculate everything.
So we have one glucose, two per
One glucose,
Two acetyl
2 pyruvate,
Yeah.
2 times acetic acid cycle.
2 acetyl-CoA, 2 citric acid cycles, citric acid cycle.
Yeah.
No, therefore, this is 2 multiplied by 3 NADH. This is 2 multiplied by 1 FADH2. And this is 2 multiplied by 1 GTP.
Yeah.
How many carbon dioxide produced?
2.
2 multiplied by 2 CO2.
And wait, NADH is worth how many ATP?
3. And FADH2,
Can you write it down, please?
no, this is for mitochondrial respiratory chain. Just for here until here, okay? Don't mix your up. I know what you want to say. Later I again tell them. Now, what's that? Citrate synthase, what does it do? Important. Aconitase, what does it do?
It's not
Important.
important yet.
No, this is are the fucking. They are labeled them by the carbon 14 and understand that something happened here, and finally they understand the carbon is go away is a carbon from acetyl-CoA, and they understand by labeling by isotope carbon that these acetyl-CoA this go away and the cycle is always constant. Understand by labeling, but not important. Oxidation of isocitrate is important. Isocitrate could be oxidized, lose the hydrogen, produce oxalosuccinate, and it's produce alpha-ketoglutarate. Oxidation, and it's written here, oxidative decarboxylation, because it's lose the oxygen and then it's lose the carboxyl group. You see? Why do you watch it very surprisingly? This is a isocitrate alpha-ketoglutarate. You see? There is no any intermediate, but it wants to tell you the intermediate also. That's very, very important. Alpha-ketoglutarate produce succinyl-CoA. Use the coenzyme A, produce NADH. Here, nothing. Here is important. Could you please help me just to put the paper? Succinate fumarate, transposition. Not important, and just wants to remember you 2 carboxyl 1 carbonate. How does it look like? That's also important. Oh, we tell everything, just our magnification. What's this again? The acetyl-CoA. Here is important, and you know everything from glucose to that 1 ATP consume, 1 ATP consume, 2 NAD produce, 2, how many? And the final is 32, and it's written here that exactly 2.5 ATP per NAD and 1.5 for
That's
FADH2.
impossible. You can have half an ATP.
Yes, that's impossible because of that. It's randomly 2, it's randomly 3. And you should know this table for sure. Later you learn, when you learn reaction by heart, you learn all of them. Here, regulation. Very easy word. If I have a high ATP, all of the reaction will be inhibited. See, the ATP inhibit, ATP inhibit, ATP inhibit. Okay? Good?
What does T stand for now again?
Tricyclic acid. Citric acid or tricarboxylic acid. Now, AMP, it means ATP to AMP ratio is low. It means AMP is high, no ATP. AMP stimulate, ADP stimulate. Calcium always stimulate. Fatty acid inhibit. Said, oh, we are a lot. The body can use us instead of the glucose. Understand? That is very easy. Don't remember exactly the position. The exam question ask you, and you're just thinking, said ATP inhibit all of them. See? ATP, citrate, NADH, the final product, FADH, succinyl-CoA, fatty acid are final product and they inhibit. Okay? Now, AMP, ADP, calcium, NAD plus, FAD plus, stimulate.
CoA as well, isn't it?
Yeah, the CoA is a lot, and said, please use me. See? No, it's CoA. Just such like this, very easily.
So they
Don't confuse
just,
yourself.
Yeah, just ask like what is stimulant, what is inhibitor. Okay.
And you can remember it.
Thanks. So now we're done. He didn't send anything to me, anything else. We have to go on